do word problems for linear programming. Okay, it's actually very easy. It's just you guys have built systems and equations 1,000 times. It's exactly the same thing. It's building a systems. All right. So first of all, I'll give you a second to please read the word problem. Read it. Okay, so after you've read the word problem, your next step is to define your variables. And guys, anytime in any kind of word problem situation, where to go look to decide what your variables are is at the question. Okay, all the beginning sentences are just information. The question is actually saying two things. What's the profit? And then saying what quantity of necklaces and bracelets should they make each week to maximize profit. So your variables then are necklaces and bracelets. So you can say X equals necklaces, and it doesn't matter what variable you use, and Y equals number of bracelets. Now then, this becomes a fancy systems of equations, which you guys have done since Algebra 1. Okay? Now, the hint I've given you with systems is this. Money goes with money, right? Yep. You got to keep them together. No different. So if I'm talking about time, all the times go together. If I'm talking about size, all the sizes go together. So this two things, so what am I talking about? I'm saying to you that some students make necklaces and bracelets in their spare time and sell them at what they make. Every week they have available 10,000 grams of metal and 20 hours of work. So what two issues do they have going on? Material and work, right? So you're going to put the grams together, okay, because that's the total, and the time together. And you're going to make sentences regarding both. That helps if you'll talk about putting them all together. All the time goes together, all the grams or amount go together. Now knowing that, read it and try to come up with two sets of data. It's two variables, you need two systems at least. Sometimes there's 3, sometimes there's 4, you'll see. Write the systems. Okay, so 50 grams of metal, right? So to make a necklace. And 200 to make a bracelet. And it has to be less than or equal to 10,000. All right, they can't use any more than 10,000. Remember, we're looking for a feasible region, so we need an inequality. The next one is time. 30 minutes to make a bracelet, and 30 minutes to make a necklace, and 20 minutes to make a bracelet. So that would be 30 minutes for a necklace plus 20 minutes for a bracelet. But time is in 20 hours, so you're going to need to convert. So that's 1,200 minutes altogether. Now the next two equations are kind of given, right? And it's just, if you want to write them down for a understanding. How many bracelets, what's the least amount of bracelets somebody can make? 0, right? I can't make negative bracelets. So I know that the number of bracelets and the number of necklaces, X has to be greater than or equal to 0, and Y has to be greater than or equal to 0. Now in understanding that, which quadrant is the only quadrant I'm going to need to draw a picture in? Quadrant 1. Okay, so this is not labeled in any way because of that, right? Everyone would be a little different. But guys, in reality, you're going to have a positive amount of bracelets and necklaces. Okay, so that's important to keep in mind. So what they're telling us then is this x-axis represents number of what? Necklaces. The y-axis represents the number of bracelets. okay? And before we decide what we're gonna count by, let's get these in graphing form, okay? So these are easy to graph. So if I was gonna graph this, this is x equals 0 and y equals 0. That's not a big deal. Okay, we already know that my shaded region is this quadrant. But I can't graph these, so I'm gonna give you another minute to put these two equations in y equals form. Okay? Put them in y equals form and then we'll move on. Alright, so when you wrote this in y equals form, the first one you should have gotten y is less than or equal to negative 1/4 x plus 50. And then the second one was y is less than or equal to negative 3/2 x plus 60. Okay, when I'm gonna graph these two, I'm starting this at 50 and this at 60. So if you're looking at these, what should I maybe count by? Right, like 5s or so, not 1s for sure, because I have to go to 50. Okay, so if you're gonna count by 5s, then I'm gonna skip a spot just for simplicity here. So I counted by 5s. I wrote by 10s, but I skipped a spot. Now then graph both lines, please. Okay, but in regards to that, if you're gonna graph this first line, watch for a second. I'm gonna go to 50. You see me? I'm gonna go to 50. I'm gonna put a point there. Let me talk to you about the slope here for a second. When you're saying, it's saying negative 1/4, so down 1/4, you can use units. You don't have to actually go down to 49, right, and over to 46, okay, or over to 10. It doesn't matter. Watch. Negative 1/4, I'm going to go down 1 unit over 4 units. Down 1 unit over 4. Right, because I counted by the same unit. It only works, obviously, if everything is the same, x and y are counted by the same unit. Okay, so there's your line. Mine's not very straight, sorry. Okay, that's line 1. Now let's graph line 2. Go to 60. And this time it's 3, 2. These lines are not going to be as pretty. And that's okay because we're just using them for a picture. Now, if we look at the shaded region, the first line is shaded less than, which is down, and the second line is shaded down. So the feasible region in this case is here. Right? Okay, let's find our vertices. Okay, how many are there? Now you might want to watch so you can find them with me. Here's one. Doesn't matter what order we go in. What is that one going to be called? That's an easy one. 0, 0. That's generic. Okay. Now go up to this one. What's this one called? 0, 50. Okay, and there's two that are a little bit harder. Okay, so if you want to take notes on how I found these, you can. But I've got this one and this one. Those are the two that are harder. Agreed? I didn't draw this one to scale very well. But these are the two. Okay, now, let me ask you a question. This vertex, okay, comes from this line. Do you agree? Which is line 2. It's this line right here. right? Or you can look at it as this line right here. It's called the what? The x-intercept, right? So go back and look. Do y'all remember how to find the x-intercept of a line? Do y'all remember what to do when you find the x-intercept?
Plug in 0.
Yeah, you plug in 0. This goes away, doesn't it? Okay, so if you're looking for the x-intercept, then that means that the y value is 0. So the y goes away. 20 times 0 is gone. So that means that it's 30x is less than or equal to 1200. So what's 1200 divided by 30, guys? What are you going to get there? 40. So if your picture isn't perfect, then you can just go mathematically find it. Do you understand? Let me ask you another question. Which of these lines, this pink line or this purple line, is easier to find a y-intercept in? I'm sorry, an x-intercept in. Which of these is easier to find the x-intercept in?
First one.
This one, yeah, because I just go away and divide. Whereas this one, if the y disappears, I have to move the 60 over and multiply by 2/3. Do you see? It's a lot easier to find it in standard form. All right, now then, the only one we haven't found is this. Okay, let's think about, how do we find the intersection of two lines? What are some ways we've done it before?
Put it in the calculator.
Put it in the calculator. We can do elimination, substitution, Kramer's rule. We've done matrices now. Lots of different ways to find the intersection of two lines, right? Okay, you can do any of those. You can set up a matrix and do an inverse matrix. You can do Kramer's rule. You can do the calculator. I'm going to show you the calculator because I think we need more practice with that. All right, so turn on your calculators and go to the y equals. Okay, and you're going to enter in both of these into your y equals, please. If they're already in there from the class before, that's fine, but your window is going to need to be adjusted, and you need to learn how to adjust the window. So, if you want, you can second 7, 1, 2, or whatever, clear out the whole memory, or not. It's just up to you on how much practice you want with it. Okay. Here's where kids have trouble. When you get ready to graph this, okay, and I realize that because some of your windows are already adjusted, when you get ready to graph, what happens when you can't see your graph? What are you supposed to do? Adjust the what?
Window.
The window. And guys, you already know the window. It's right here. You graph the whole thing. So go to the window and change it up a little. The first thing it talks about is the x-axis. What were we needing here? We needed 0 to 40. I'm just going to put 0 to 60 just to have it. And I'm going to count by the same thing we did, 5s. Then it goes through the y values. Look at your y values. What do we need? Maybe 0 to 70. Count by 5s. Do you agree? You'll see where I'm getting it? I'm looking at my picture. This is the x value, this is the y value. Then you graph it again, and you can see it. So when you can't see your picture, change the window. Does anybody remember how to calculate the intersection?
You can just look for a table.
You go to second calc, because you want to calculate. And what do we want to calculate, guys? An intersect. So hit enter. It's going to say first curve. Okay, so I'm going to get closer to my point of intersection way over here. First curve means the first line. I'm just going to come over here closer to the point. So there's my first curve. I'm on the first line. I hit enter. Now you're on the second line. I'm going to go down a little. Get near it. Hit enter. And hit enter again. And there it is. Where do they intersect at? 848. So this is 848. A lot better than some of the ways that we've done it before. Okay, we have not written one very important thing. Okay, the question asks about profit, doesn't it? have we written anything about profit?
No.
The question says, what's the maximum profit? Have we written anything about profit? No. Did it give us any information about profit?
Yes.
Yeah. Okay, they make $350 on a necklace and $250 on a bracelet. That's where this is. So your profit function is $350 for a bracelet, no, a necklace, and $250 for a bracelet. So what do you think you're gonna do with these 4 points you found? Plug them in. When you plug these in, okay, 350 times 8 plus 250 times 48 gives you how much money, guys?
148.
148? And your goal is to plug each one in. So which one is the maximum, guys? Yeah,
148.
148. So the answer then is you need to sell, this is the X value and this is the Y value. So I want to sell 8 what? Necklaces? And 48 what? Bracelets. That's the best way to get $148. That's the best way to maximize your profit. When you're talking about time, wait guys, I have 3 minutes left, just sit and listen. Okay? When you're talking about time, which is one of our constraints, materials, right? I only had 10,000 grams, right? So if I've got 10,000 grams in 20 hours of work, and I'm gonna charge $250 for bracelets and $350 for necklaces, this is my maximum profit to get. If I can get 8 necklaces sold and 48 bracelets. Okay?
Ice. Hey.
You guys, it's not
Look, today. Went in on that.